Good morning, this is Jeffrey here at JTech in the diesel program. Today we're going to be talking about torque converters. We've got this torque converter here. It goes to an Allison 600 transmission, and I'm going to just go over a brief explanation of the parts and how it works. So first, you take a look at this. Is what part of the torque converter that would be mounted onto your flywheel or flex plate. This is so turned by the engine. Then open this up. See the insides here. Torque converter here, you have your clutch assembly. There's a piston in here that's powered by hydraulic fluid, and that will cause this to lock up. When it gets to that point, we'll explain that later. This part of the clutch assembly is your wear surface, or I'm sorry, your this part of your clutch assembly. This is where your friction material will rub against while it's under pressure. And then here's the main internal parts of the torque converter here we're going to talk about. First, you have your turbine, which consists of these vanes that direct the fluid flow. You also have your stator here, which is in between your turbine and your impeller. Now, as the torque converter is spinning, it's going to cause the fluid to flow through the vanes towards the outside of the impeller. As it goes out the impeller through its centrifugal force, it's going to enter the turbine, which is going to cause the turbine to spin. Now it's going to enter the turbine through these vanes, then exit through the center. Normally what that would do would be causing the fluid to flow in the reverse direction, and that would actually slow your impeller down. So in order to prevent that, the stator was invented, and what this does is it sits in between the two, and it sits normally in a locked position, so when you're first accelerating and you need that torque multiplication, the fluid will actually come through the turbine here, and as it comes out of the center of the turbine, it's redirected by the angle of these vanes, which redirects the flow, allowing it to flow in the same direction as the impeller. So now you have torque multiplication, and it prevents you slowing down your engine. Now, what that's called is vortex flow. And vortex flow, the stator's stationary, and you're getting a very high-powered torque multiplication. Now, as the impeller and turbine begin to speed up as you're accelerating, once they get closer and closer to the same speed, the stator will actually begin to freewheel inside. Now you'll have a portion of vortex and what we call rotary flow, where the turbine is spinning. You won't usually have just one or the other. It'll be a mix. Now once you get up to about 90% where the turbine and the impeller are spinning at about 90% of the same speed, the stator at that point is freewheeling. It's just in there spinning because the flow of the fluid no longer needs to be redirected. It's all spinning in the same direction. That's called rotary flow. Now, once you get up to that 90%, your transmission will recognize that, and it will activate what we talked about earlier, the clutch. What this will do is a lockup clutch, and it will lock the unit down as one. At that point, the turbine, the impeller, it's all spinning at 1-to-1. It becomes one unit, and it's no longer a hydraulic motion. It's more of a mechanical motion because it's all locked in together. So that's really what you're looking for. It's the most fuel-efficient way to do that. And you're no longer getting torque multiplication, but at the speeds that you're traveling at that point, you no longer need that because you're no longer accelerating, you're just maintaining your velocity. So those are the most important parts of your torque converter here. And the most important thing is without the stator, you'd never have any torque multiplication, and it'd be really hard to get your vehicle moving from a standstill. So the stator is really important to get you that torque to get moving. But once you're moving, and this is freewheeling, you're in rotary flow, you don't need that torque anymore. You just need to have the good stable movement of your fluid, which is going to allow you to maintain your speed. You're no longer accelerating. And then get your clutch in there, lock it up as 1-to-1, mechanical motion, and at that point you're most fuel efficient. Those are the most important parts of the torque converter here. Now, inside of here, this piston that does the lockup clutch, there's also springs inside, because if you don't have those springs, as when you lock this up as a mechanical unit, you're going to get the engine vibrations through your driveline. So there's springs in here which are going to dampen those vibrations so you don't feel them through the vehicle. That's important because if you get too much vibration in your driveline, you're gonna tear stuff up. And then you also have a pump in here, which will attach to your transmission. All of this spins through your engine, through your flywheel, torque converter here, to get you the power to your transmission to get your wheels moving. So that's basically it. If you have any questions or comments, please leave them after the video.